to do that. All right, so I wanted to talk about the new assignment, and what the new assignment is. Let me go to Blackboard real quick. It's going to be located in Blackboard, and let me drag this over. So when you get into Blackboard, you'll come over here and you want to click on your daily work projects right there. And of course, we've drawn the ones at the top. You can scroll down, you can see everything we've done so far. And then you're going to get right down here to project number 6, because project number 5 was the actuator base. And if you haven't submitted the actuator base, you do it by clicking right here and uploading a PDF. So then you're going to go on to part number 6. It's called the bracket 1433. This is the sketch for the bracket 1433. All right, and so if you look at that, you may say, well, you know, how would it be a good place? How would I start on this project? And so what I'm going to recommend that you do is that you draw this profile, and the profile is going to be 8 inches long. This right here, you would draw a long line 8 inches long. Then you're going to come straight up 1.25, and the height over here on this guy is 1. So this plane here and this plane here are not coplanar. The back plane is higher than this plane is right here. So you're going to come in from this very front point right here. You'll come in 3 inches to the front of this, and then you're going to go 1 inch more. The overall height of this guy is 2 inches, because that's where your center of this is, plus you have a radius right here, and the radius is 1.5. So the overall height is actually 3.5 inches, okay? You have an angled plane right here that is, let's see, should be in there. There it is. It says 45 degrees right there. So that's the angle of this plane is 45 degrees. And then you have a slot that's cut through, and that slot is normal to this angle right here. And so when we say it's normal, that means it's cut perpendicular to that angle, so it's going to go through at a 90-degree angle. So this slot does not run through the entire length of the part. It just runs straight through from this angled part that we have right here. Okay? So, you know, I want you to like first study this and get an idea of, you know, what the dimensions of the part are, and think about how you might model it. And there's something right here. It says full R, F-U-L-L-R, and it points to this radius right here. What that means is that we know the width of this part is 3 inches. That's what it tells us right here. But that 3 inches has a tolerance of plus or minus, you know, 0.01. And so that means that the width of that part might be 3.01, or it could be 2.99. And that would fall within its size limits. And so what we're saying when we say full radius, full R right here, is whatever that width is. If it's 3.01, we want that radius to be 3.01 as well. And if it's 2.99, we want the radius. We want a full radius on that. And by full radius, we want it to match the width of the part. That's what we're talking about here. We've got some GD&T on this one. Datum A is right down here at the bottom. And then we have a flatness symbol for the bottom plane. And then over here we have a perpendicularity symbol for GD&T. So this surface right here is perpendicular to datum A. And remember, datum A is really not the bottom of the part. It's the bottom of the part after you set it on a surface plate, okay? So we want to imagine that we have two perfectly perpendicular planes, perfectly perpendicular to A, that are 5/1000ths of an inch apart, and that every point on this surface of this vertical plane right there would fall between those 0.005 planes that are sort of our target datum planes. Over here we have another GD&T on a hole, and this is a counterbore hole. And so the size of this counter bore is a diameter of 1, which is the smaller hole that goes all the way through. And then the diameter of the counter bore is 1.25. That's this larger hole right here. And that has a depth, that's the depth symbol, of 0.125. And the parallelism means that the center axis of that hole should be parallel to A within a cylinder that has a diameter of 0.005. So what I want you to imagine is that you have a very small cylinder that's perfectly parallel to datum A, and that the diameter of that cylinder is 0.005. So that's 1/1000th of an inch larger than the thickness of a sheet of printer paper. That's how small that cylinder is. And that the center axis of this 1-inch diameter hole, that three-dimensional axis, has to run through that cylinder or it won't pass inspection for geometric dimensioning and tolerancing. So we're really trying to control the parallelism of the center of this 1-inch hole. Now, we're not controlling it for the counter bore, because if we were, this note right here would be below this so that it would apply to both notes, but because it was placed right beside the diameter 1, then it only applies to the diameter 1 hole over here. And then over here we have a counterbored hole that has a diameter of 1.5. That's the smallest hole that goes through. And then a counterbored hole that has a diameter of 2 to a depth of 0.13 for the counterbore's depth. Now, the reason you need to understand all that is, when you build these holes using Inventor, when you click on counterbore tool in Inventor, you have to define, what the diameter of the smaller hole is, what the diameter of the counterbore is, and what the depth of the counterbore is. So you do need to understand how to interpret all this stuff. And then right here on this hole, it says 5/8, so that's the diameter, dash 18 UNF dash 2B. So that is a thread note. So that's a threaded hole right there. And the way you interpret that is that the major diameter of that thread, so I want you to think, when you cut thread, it cuts to a depth. The major diameter is the deepest cut on the diameter of that thread, and that has a diameter of 5/8 of an inch, right? Dash 18, that's the number of threads per inch. So this piece right here is actually 1 inch tall, and because there's 18 threads per inch, we would expect there to be 18 threads in that hole right there. And then the thread series right here stands for Unified National Fine. So this is fine thread. And dash 2B, this is called the class of fit. Class 2 fit is like the kind of thread you would expect to get at a hardware store. All right. A class 3 fit is much closer tolerance, and a class 1 fit is really loosely toleranced. And then a B indicates that it's internal thread. So the thing about this is, if you had to buy a screw that would go into that hole right there, the thread on that screw would be exactly the same. It would be 5/8-18 UNF-2, except instead of a B, it would say A. So external thread is a 2A thread, and internal thread ends in a B. All right. Okay, so anybody have a question they want to ask right now just about this sketch? So this is located in Blackboard. So that's where you'll find it. Okay, so what I'm going to do is switch over now, and I've already started drawing this project, or already making this project. And so what you can see is, here's my sketch. You see these red as I move those lines over? So all those lines that are blue right there, that is my sketch. And you can see I have my dimensions on there, and I used the same dimensions that I saw on the sketch that's in Blackboard. All right. Now, once I have this sketch done and I finish the sketch, I'm going to use the extrude command, and the distance that this is extruded right here should be 3. And so I'm going to type 3 and enter. And so there's my extrusion. All right. And so when you look at the sketch of the part, it kind of seems funny as to why I would have chosen to just, instead of making these round right here, why did I just extrude all of that with square edges on it? Well, the reason for that is I'm going to use the fillet command, and because this distance is 3 right here for the whole width of it, I'm going to use half that for the radius. So I'm going to use a fillet of 1.5. Okay, so the way I'm going to do that one is just go up here and use my fillet command and set my fillet to 1.5. And then it says select edges. I'm going to pick that edge and pick this edge, and I'm going to pick on this corner, and I'm going to pick that corner there and pick OK. All right. Now, for some reason my part's a little dark. Let's see if we can change what we're seeing here. Should be able to control the material for the part right up here where it says default. Now, you're not really controlling the material, you're just controlling what it looks like. So if I choose something that is lighter, let's see if there's anything lighter I can get in here. Chrome, chrome's going to be too dark. I don't know why it's so dark, but let's try gunmetal. That one's too dark. Why is it doing this? Let's go up. If you go up to the very top, there should be just a default. There we go. So the default is just really dark looking on my screen today, so I apologize. Hopefully you guys can see that okay. All right, so the next thing that you would want to do probably is to add those holes here and here and here, and I would just use the hole tool to do that. So I would pick on hole and pick on this surface, and remember, if you pick on that edge, it should center that hole in the center of that radius, and that's where you want this to be. And then you want to choose a counter bore for that one, and the size of your counter bore on that particular one, if I drag this over here, that counter bore has a diameter of 1 and a counter bore of 1.25 with a depth of 0.125, right? So I would want to set, go in here and set this to 0.125 right here and set the width of my hole. Now, for some reason, I've got a threaded hole and I just need a simple hole on that. I don't need a thread. And so I want that to be 1, and I want this width right here to be 1.25. And I want the depth to be 0.125. And at that point I can pick OK, and there's my counterboard hole. And I would continue to place the holes that way. So the one I wanted to show you guys about, though, is that there is this hole that goes, there's a groove that goes all the way through the part right here. The width of that groove is 1.5. The height of that groove is 0.75, and it's located 0.75 from the left-hand side of the part. So what I want to do is start a new sketch on this angled plane. And the reason that that plane is angled is just because I drew a 45-degree line and then extruded it out. So I would right-click on this and choose a new, let me right-click on that, and choose a new sketch, all right? And so I would just go in here and draw a rectangle somewhere like that. And actually, if you wanted to go ahead and define it, you could say 1.5 tab 0.75. Let me back off on that and enter. All right, so what the heck? Oh, it went the wrong way. I see what's going on. I don't want it to be in that direction right there. So let me just put a dimension in. On this one, I want that to be 1.5. And I want this height over here to be 0.75. And I want the distance from this side to this edge right here to be 0.75 and enter. Now you don't want to model it from the back edge. You want to model it from the leading edge because that's what the designer's sketch shows us to do. And then I would finish that sketch. All right, so at that point you're going to do an extrude, and you're going to pick on that, and you want to do a cut. So you want to go through it like that, and you want it to go through all, and pick OK, and there's your cut. And so if you look at that, if you go over here and you look at the right side view, you can see it does not go all the way through the entire thing. It just goes through perpendicular to the plane that's highlighted right now. Okay. There's a few more fillets and things that you're going to add to this guy. And let's see about, like, for example, it says 2 times radius 0.13. So there's a fillet right in here, a small fillet here, and there's a small fillet over here on the back side as well. And I think that's pretty much it. You'll add your everything to that as far as your GD&T and things later when you make the drawing of it. Okay, so let's talk about starting to create the drawing. What you're going to do is open up your ANECAD B Proto.idw. So the ANECAD B Proto, this is the same one you've used before. You're going to open it up and you're going to do a save as and save it as bracket 1433. And where you want to save that is in My Drive, and then inside your 1433 folder where you're keeping all your daily work drawings at. Okay, so this is where you want to save that model, and then you're going to open up this ANECAD B Proto and save it as bracket 1433, and then we're going to add the necessary views and dimensions and all that. And so all I want you guys to do before next week is to model the part, open the prototype, and put your views in. You don't need to dimension this thing yet. I want to talk about the dimensioning before we put dimensions in. So on Tuesday morning when we're back in class, I want you to have this with the views, and I'm going to show you the views right now, what the views are that I would like to have for this. All right, so let me go to Inventor here. So what you're going to do is start like an ANECAD B Proto, and then we're going to add these views to it. Now we're not going to put any dimensions in there yet, so I'm going to delete all of this stuff out that I have. So once you open up your ANECAD prototype and you save it as bracket 1433, I want you to go to Base View, and then you're going to go Search, and I want you to find the, let me see if I can find my bracket 1433 real quick. It's in my daily work, bracket 1433. There it is right there, and pick Open. Now, this is not the view that I want. I actually want what would be the top view relative to this. So you can see that the view cube is over here. I would go at the very top, you see that triangle on the top. If you pick with that on your with your left button of your mouse, it turns your view. This is the view that I want to be the top view on this. The other thing on this one that I want to make sure that I'm saying this right, is that should be 3/4. Let's see if I have this one open. I think we want this to be 3/4 on our scale, and I'll be able to tell here in just a second if it's not. And I don't want it to be shaded, so I'm just going to pick OK and see what I have. So there's what my principal view is going to look like. And then I would pick projected view, and I would pick on this view and move right out over here and pick, right click, and pick create. All right. So I've made a video for how to do all of this stuff, and it is in Blackboard. And in that video, I start adding center marks and dimensions and all. But we're, like I said, we'll talk about that on Tuesday when we get in class. So if you come to class and you just have it this far, that would be great right there. Because what I'm going to show you is how to make a section view. So we have a tool right up here called Section. And what it wants to do, it says, if I look down at the bottom left, it says select the view that you want to make a a section of. So I have to pick on this view right here. Just pick to the edge of it like that. And then I'm going to move my cursor up here until it snaps right on the quadrant, but I'm not going to pick. Don't pick yet. Just let it snap to that quadrant and then move out about 1/2 inch, because where you move out, this is where the arrow for your cutting plane line. Now, hopefully you remember section views from when you took 1405. So we're going to move out maybe 1/2 inch, something like that, and we're going to pick with the left button, and then we're going to go all the way through the part, and we want to make sure that we're not at a slant, that we're actually staying horizontal. And we want to move out to the right of that part and pick again, and then we're going to press right click and choose continue. And then if you move your cursor down right in here, what Inventor is going to do is give you a section view of this. Now, you can go ahead and just pick if you want to and let it build the section view. But when it does that, it adds some letters up here. This is section CC, and all that is down here. And you really don't need all of that. So I'm going to double click right here and see where it says section. I'm just going to highlight all of that and delete it and pick OK. And that's going to take that out. And let me see if I double click up here, if I'm going to get it. I think actually I'm going to have to double click on this one again. See, okay, right here where it says label and it says C, I'm going to delete that, but then you have to put a space. You need a placeholder in there and then pick OK, and then that takes that out. So what we've done is created a section view of our part that looks like this. And the reason we want that section view, that's going to help us dimension this cutout that we have here, because it's hard to dimension that cutout in this top view because it doesn't run all the way through and it just goes through normally to that. We're actually going to place some dimensions on there, and that's what I want to talk about on Tuesday, is how to dimension this and why you dimension it the way that you do. So you don't need to dimension it, just make these views here, and there is a video in Blackboard that will show you how to do that. So let me click on Blackboard and just show you where that video is located at. All right, so as I said, your sketch and everything is right here. That's part 1. And part 2 says create a working drawing. And let me see, there should be a video. Here's my video. Under step 3, there's the video. Follow your instructor's directions to create an Inventor drawing, including the necessary views. And so you'll click on this link right here in step 3. As I said though, don't put your dimensions in. Just bring all of this to class with you, or save it in your shared drive of your My Drive, rather, of your Google Drive. And then we'll open it in class next Tuesday. And I want to talk about creating a dimension style and adding dimensions to all this stuff at that time. And so that's how we'll approach this, okay? So you don't need to submit it yet, but you do need to just make the 3 views that I showed you here. So of course you'll have to make your model first to do that. All right, so with that, I think I'm pretty much done. And I'm going to open it up to see if anyone has any questions they want to ask about it.